Assalamualaikum and salam sejahtera. Today we will continue our lesson for EBT 449 Environmental Friendly Polymer. Okay, for today's topic will be about the application of biopolymers. Okay, first we need to know what is the use of biopolymers. The majority of commercial available biopolymers can be processed using existing equipment and have physical and mechanical properties similar to existing polymers. So we need to know that, okay, for even though it is a biopolymer, to process a biopolymer and become a product, the equipment that can transform this raw material to a product is still similar to the conventional uh, plastic or conventional polymers. Therefore, we can still use the existing equipment and the physical and mechanical properties are similar to the existing polymers. There are there is there exists a number of end-use applications for biodegradable polymer, but by far away, the most popular is the manufacture of compost bag. So, biopolymers can be turned into many end products, but the most important or most popular is compost bags. Okay, this is a pie chart show the use of biodegradable plastic within Europe. Therefore, we can see that majority or half of the biopolymer are turned into a compost bag, which is 50%, and a quarter is turned into a loose fill, which is 25%, and another is paper coating for 12%, and food packaging 8%, and others. So, therefore, that's why it's already concluded that most application for biopolymer is throughout the compost bag, and then a quarter is turned into a loose fill. Loose fill is similar to the styrofoam that have been used, okay, where we needed it to fill inside a packaging, okay, to avoid breakage or to make it more compact. It's like a styrofoam. Okay, use of specific polymer type. Okay, first we look for lignin. New research have shown that lignin can be combined with cellulose to produce a moldable material with similar properties to wood. Lignin-based polymer have been used for mold making and in polyol production for the manufacture of polyurethane. So lignin have been used, okay, to make more materials which have similar properties to wood, and lignin-based polymers have been used for making molds, okay, and the polyol production for the manufacture of polyurethane. So there are three main applications for lignin. First is turn into a properties of turn into a product which have similar properties to wood. Second is turn into a mold, okay, and then turn into a polyurethane. Okay, for example, lignin is obtained from trees, okay, and then the lignin are combined with nitrate rubber. Okay, this combination of lignin and nitrate rubber, we make it into a thermoplastic product through a extruder. Okay, the extrudate, okay, will be used whether inside automotive industry or else covered by another applications. Okay, this is example of lignin use product or applications. Okay, this is example of a chair that is made by lignin. Okay, comb. This is a comb brush. Okay, your hair brush. Okay, chair. Okay, and then this is the real product that can be found inside our market. Okay, and then the properties of this product, okay, are usually similar to the woods. That's why they are preferable to use lignin. Okay, and then lignin also can be obtained from the biomass feedstock. Okay, and then this lignin will be the lignin base for polyamides. Okay, and then the soybean, okay, we can extract the soybean oil from the soybean, and then the soybean oil will be the cyclic carbonate. Okay, this will be to perform the polyurethanes. Okay, this is an example of polyurethane made from biopolymers. Okay, this is a foam, this is your pillow, and then these are some soft rubber toys. Okay, oh sorry, urethane toys. Okay, then lignin-based thermoset, adhesive, and elastomer system have all been developed. DNA have been tested as a stabilizer against attack from microorganisms in the other biodegradable polymer system. Okay, next is about the hemicellulose. Hemicellulose have been used in applications such as adhesive, medical gel, and polymer reinforcement. But mostly, okay, we hear that hemicellulose are majorly used as a polymer reinforcement. Okay, okay, this is an example of a research, okay, or a published journal conclude that hemicellulose as a constituent in a green wood adhesive. So hemicellulose can be turned into an adhesive to higher the wood. Okay, moreover, hemicellulose also can be used as a medical gels are used as a medical product. This is example of hemicellulose which can be found in aloe vera gels, which consists of primarily of water and polysaccharide, mostly pectins, hemicellulose, glutamate, Asycn, and mannose derivatives. Okay, so the hemicellulose also can be used as a medical product, mostly in medical gels. Okay, and then this is also one of the most popular biopolymer, which is starch. Starch-based polymer have been used in many areas, include hot melt adhesive, injection molding materials, packaging, film, foam, tires, painting, and horticultures. Okay, and then from the starch products, okay, this is mainly the common application that can be found, okay, consume of starch. Okay, first is in cosmetic, beverage, syrup and dessert, confectionery, bakery products, puddings, gravy and creams, instant noodles, colors and painting, weaving and textile. Okay, so mostly this is textile, the clothes, okay, can be produced from starch, medicine, pharmaceuticals, paper and glues, ceramic and construction, spray concrete. Okay, so there are many applications that can be covered by starch. Okay, November metal biomaterials have been used in a wide variety of applications, such as composting bag, food, fast food tableware, soluble foam for industrial packaging, film wrapping, laminated paper, food container, mulch film, nursery pot, plant labels, disposable nappies, and cotton swab. This is mostly the use of biopolymers contributed by the November metal materials. So based on our previous lecture, okay, we also already discussed why November metal B is very important. Okay, there's the November method B is important because this is a method, okay, where we can desaturate the starch. Okay, and then the desaturate of starch is very important so that we can enhance the properties of the starch. Okay, and then polyhydroxy alkanoids, okay, are found in medical applications such as in composite with hydroapatite. They also have potential in food packaging application. Metabolics claim have Meta- Metabolics claim to have found a new cost-effective means of producing this material. So PHA, okay, okay. Application of PHA in medical and pharmaceuticals structures, okay, temporary heart valve, bone graft substitute, carrier for drug delivery. So we know that PHA is a very fine. It's not very fine. It's a very expensive materials that are produced by microorganisms. Therefore, you need to expect that the price of using PHA is quite high. However, in medical application, okay, the quality and the grade of the material are considered as important elements. Therefore, okay, we need to produce medical equipment which have a good properties as well as suitable for human and suitable to be used in human bodies. Okay, and then this is how we produce, okay, sorry, products from PHA. Okay, first we have the waste of feedstock, okay, such as from sugar beets, corn, sugarcane, and then the PHA granules accumulation inside the bacteria. Okay, and then the PHA is extracted from the bacteria, and then the PHA will be used, okay, to turn into a desirable product. Okay, tannin. Tannin solution are acid and have a astringent taste. Tannin is responsible for the astringency, color, and some of the flavor in tea. Tannin occur normally in the roots, wood, bark, leaf, and fruit of many plants. So if you drink your tea and then the flavor of tea is actually caused by tannin. Okay, and then the bioresources, okay, usually from the wood and algae, okay, and then we can obtain the tannin. However, before we can turn this tannin into a material polymers, okay, the tannin itself need to be modified to enhance the properties. Despite of enhancing the properties, okay, the modification also is important to ease the processing of tanning so that it is easier to turn tanning into a polymer product. Okay, uses of tanning usually are in dyes, fibers, glues, oil, waxes, flavoring agents, drug, perfume, potential source of new natural drugs, antibiotics or insecticides and herbicides. Okay, next is the cashew nut shell liquid, or as we call as CNSL. Okay, first of all, this is a picture of cashew nut. If you're not very familiar what is cashew nut, and I believe that you guys love to eat the cashew nut. Actually, this is the cashew nut. Okay, and then to obtain this cashew nut shell liquid, okay, it is not as obtained from the cashew, but it's from the nut shell. Okay, this is the process how we can obtain the CNSL. Okay, the cashew nut apples. Okay, first we need to obtain the nuts only, and then when we obtain the nuts need to be split into two and remove the inside remaining. Okay, so we need only the shell. Okay, okay, first we need to clean and sizing the nuts. Okay, and then we need to conditioning it with water. And then the nuts is then being roasted. Okay, roasting under the heat. And then it will drain and cool. Okay, and then centrifuge. Okay, through this process, okay, actually we already can obtain the cashew nut liquid. However, the optimization, okay, needs to be followed by this step. First, we need to roast it, and then we need to drain, and we need to centrifuge. However, during this roasting itself, okay, cashew nut shell liquid already can be obtained. But to optimize it, okay, centrifuging is required to optimize the amount of output of the CNSL. Okay, and then the CNSL is being distillation. Okay, and then we have the cardinal. Okay, what we call as the oil. Cashew nut, cashew nut liquid formaldehyde resin have been developed. Okay, cashew nut liquid have been used in coating application. First, CNSL have been used as a coating application. Phosphorylate cashew nut liquid have been added to natural rubber to improve the flame retentancy. Okay, despite that, CNSL also been used as additive inside rubber to improve the flame retentancy. Okay, and then the thermoplastic PU have been prepared from cardinal. Okay, please focus on this. Cashew nut liquid have been used in composite with natural fiber for possible construction application. Okay, and then this is about the polylactic acid PLA, and then we know that PLA is obtained from corn or the maize. Okay, first polylactic acid. Okay, polylactic acid is a very popular biopolymer and already been widely used throughout the world. Okay, and then there are many types of PLA products that can be found on the shelf, on the market shelf currently. Okay, and then PLA products, okay, already being used as in transportation, in packaging, in biomedical, in textile, in electronic application, and agriculture. Okay, this example of PLA packaging, okay, mostly that it is more favorable to use PLA as a packaging because PLA is easier to degrade compared to the conventional plastic materials. Okay, and then for example, if you see that, okay, mostly outside of Malaysia, okay, in the modern countries, okay, the packaging are required to be manufactured from biopolymers, okay. And then even though fast food restaurant chains such as McDonald's, okay, outside of Malaysia are practicing of using PLA as a source of packaging for their food, okay, despite of using their conventional plastic. Okay, and then this is the agriculture. Okay, PLA also have been used to make the plastic mulch for agriculture. Okay, and then this is a very important application in agriculture because when we use biopolymer as a material in agriculture, okay, there the farmers can reduce the cost of farming. Okay, for example, okay, if you are using a conventional plastic material or plastic film, okay, the mulch, okay, after the plant, okay, have been used, okay, or farm, okay, or harvest, okay, the mulch needed to be taken out. But however, if biopolymer material is used as the plastic mulch, okay, they can be used again, and then the farmer doesn't need to take out the material because this material biopolymer can degrade easily and faster in soil. Okay, so they need only one step of process despite of two step of process when using conventional thermoplastic. Okay, and then this electronic, okay, mostly applications such as handphone casing, okay, they are being manufactured from PLA. Okay, and then the textile, okay, mostly shirts, okay, we can see that is made from PLA. And one interesting materials that I read about, okay, Adidas itself started to use plastic as a source of materials, okay, to produce their sneakers or sport shoes. Okay, and then this is about chitosan, another biopolymer. Chitosan has potential for biomedical application. Okay, when we speak about chitosan, okay, you need to know that chitosan is obtained from organic compound which found in crabs and shrimp shell as well as insect. Okay, so any insect or crab or shrimp, okay, that have shells, okay, chitosan can be found. Okay, and it's an easy process to turn from chitosan into a plastic. So next time when you have your meals at Kuala Place and then you eat some prawn or shrimp or crabs, okay, just take the shells, okay, to your home, okay, and then the shells, okay, you need to clean it. Okay, after you clean, the chitosan from the shell is chemically mixed with carboxylic acid and then left to solidify. Okay, and then once it's solidified, okay, the acid will evaporate. The solid chitosan acts like a thin films that can be used as a biodegradable plastic. So you have your shell or shrimp, okay, and then chitosan, okay, will be mixed with carboxylic acid, okay, and left to be solidified. Once the acid have been evaporated, okay, you will be left with a plastic film, a degradable plastic film. Okay, and then chitosan or chitin, okay, the application for this material are usually in biosensor. This is a famous material. Okay, and then tissue engineering, okay, wound dressing, antibacterial, and drug delivery. Okay, and then moreover, application of chitosan, okay, have been worldwide used, okay, in biomedical and pharmaceuticals, chemicals and industrial, cosmetic, food and nutricals, fruits and vegetable storage, water purification, agriculture, fiber and textile, paper, paint, and leather. Okay, this is example of products that are made from chitosan. They have their shrimps, okay, they mix with carboxylic acid, and then they left the carboxylic acid to evaporate. Okay, and then they have their film. The film are then being turned into a product, whether by a transfer mold, okay, and then they will obtain a desired product. Okay, this is a product of chitosan which is already in the market, what is called as a Chito Clear. Okay, this is a food supplements, nutritional, biomedical, and cosmetic products. Okay, for details, you can go to this website, okay, and have a look. Okay, the use of biopolymer in specific application is, as in the case with other material, governed by price. Okay, that's why we say that biopolymers, okay, have been used in a specific application because it cannot be used in other material because the price of biopolymer is quite high compared to the conventional polymers. The lower price biopolymers, which are generally the starch derivative and some polylactides, are used in packaging application and in production of compost bag. So this is the lower types of biopolymers. Okay, so the lower type means that the price is also lower and then it can be used in a wider application. And then for this type, okay, usually the PHA, okay, the PHA have been used only in the biomedical because it's a very expensive materials. The higher price biodegradable and bioabsorbable polymers such as the PHB are used in medical application as the cost cannot be economically justified in other market sector because what because okay, some higher biopolymers, okay, they have a good properties and is well compatible to the humans, okay, and then that is more suitable to be used only in medical application by means that, okay, even though it's high in price but it's very important, okay, and then people for health purpose, okay, people will buy the item despite of the price. Okay, I think that's all for today. Okay, thank you very much.